So now let me introduce you to my colleague Anna Barraqué. She's a team leader at CYSEC. She holds a master degree in aerospace engineering from ISA and SuperAero, and also a master in international security from Sciences Po Paris. She's currently the engineer team lead for ARCA SATLINK, a product securing the data link between ground stations and satellites. And she's here to talk today about end-to-end security for space data link. Please welcome Anna Barraqué.
Hello, everyone. So very nice to meet you. So if you have been coming to CYSAT, you probably heard a little bit about ARCA SATLINK already. I have here also in the room some of my colleagues. So we have Gabriele, Luca. Maybe you met them already before. And if not, of course, after the presentation, come to our booth and we'll be very happy to answer more questions. So today, as I told you, maybe you've already heard of ARCA SATLINK, maybe not. Today, the idea is to show you, of course, a little bit of a recap of what it is, but certainly how you can deploy it easily. So just very quick, we'll start with doing what is ARCA SATLINK, what does it do, how can I use it, has it been used? Spoiler is yes. And what's next then? So what is ARCA SATLINK? Maybe you know, with the new space companies coming, there were a lot of communications that were just clear without any encryption. And that, of course, is a very critical aspect of space systems. So then the CCSDS decided to publish the Space Data Link Security Protocol, also called SDLS. And with that, so all the different agencies around the world sat together to write this protocol. And what we decided to do was to go from PDF to code. And that code is basically ARCA SATLINK. So it is a software library that you can deploy on the ground and in space to be able to secure your telemetry and telecommand according to the SDLS protocol. That's simply it. So what does it do exactly? The SDLS, or let's say SDLP protocols, are the following. So you have telemetry, telecommand, that's probably the ones that you use normally. Then you also have the advanced orbital systems or the unified space link protocol. And SDLS can basically secure any of these protocols that you're using for your communication between your ground station and your satellite. How does it do this security? Well, a normal frame is like this. You have the header, the trailer, and of course the data you want to send. If I intercept this, of course there's confidentiality issues because I can read what is there, and there's also some authenticity issues because someone else could be sending the same type of frame and your satellite could be accepting it. So to resolve that issue, first we do encryption. So then if I look at the frame I'm intercepting, I cannot read what it is. And then we also do authentication. So using some headers and trailers to ensure that your satellite will only accept the frames that I am sending and not that my enemy operator is sending. So then how it is exactly done, we are using AES 256 GCM, as most of you probably know, but this is also modular and can be changed. And then just to let you know, that is a very, very low, let's say, security overhead, because you can have like, let's say 30 bytes only of overhead onto your frame, and this can be changed. Why? Because with SATLINK, you can actually manage your security. When we say manage your security, is that each frame will be secured according to what the protocol calls a security association. A security association, basically, it's like a little security card that will explain you what is the algorithm used, what key is used, what anti-replay sequence number is used. This is done to avoid to having replay attacks. Replay attacks basically is when I do encryption and authentication, but someone else is actually capturing the frame. It cannot read it, but it can resend it. And then that will execute that command twice to the satellite. And to avoid that, basically, we'll have an incremental number that is called the anti-replay sequence number that would reject that frame on, in the level of the satellite to ensure that these replay attacks are not done. And so with all the security associations, it's different values that can be changed, modified according to your needs. So then each channel will have its security association. You can manage, therefore, the security that you will have in the different channels. You can, therefore, have different keys for these different channels. And we always recommend to have different security. So on your TC channel, your TM channel, and then also what we will explain, the extended procedure. The extended procedures, and I think, yes, that was the next slide. There are operations that are done so that you can manage your security. So maybe you have been using the nonce that you use for your key, and you have used all the values of this key. So now you need a new key to be able to do your cryptographic operations without any vulnerability. So then you have, for instance, the over-the-air rekeying. Then you also might want to activate some keys, deactivate some keys, check the different keys that can be active on your satellite. All these are done with these extended procedures. Then, of course, you can and you need to be able to manage the security associations. So, for instance, there, for the security associations that is securing your channel, you will be able to change the key that is securing that specific channel. You will be able to, again, expire them, create new ones, etc. And then, of course, you will be able to monitor the channel. So to also dump some logs to be able to ensure that your channel is well secured and you don't have any attacks that maybe you have that has been raised. So to show you a bit and to put it more into an illustrative mode, here is a bit the different cycle of the keys. So of course, they will come pre-active, you can activate them. When they are active, you can actually rekey them, so associate them with a security association that will therefore be operational for the channel you are using. And then once on the frequency that you want, you can stop the security association, put a new key, restart your security association, and this cycle, so you would have a well-managed security on board of your end-to-end communication, sorry. So this is a bit what I just explained you. You will do an over-the-air rekeying, activate the key, rekey your security association, start the security association, then you can communicate with the satellite until you've used all the values that are possible with the nonce with your specific cryptographic key. Then you stop it, you can expire, etc. So now that we understood what it does, so basically securing and managing the security of a link, how can I use it? Very simple. You deploy it on the ground and in space, of course, to have the end-to-end encryption. On ground, it is basically a Docker image that is provided, that is coded in Rust. And then on space, it is a C compiled binary. So it comes just when you are actually handling the frames. So we come before you do any encoding of modulation of your frames. And of course, you will be then doing the workflow that you want with the frame that you received and has been secured. The two functions that you see here, apply security basically is to encrypt and add authentication to the frame, and process security is to be able to verify the frame and then, of course, decrypt it. Now, let's put it in a real case satellite. So for your ground infrastructure, you will, of course, have to have a little integration, have the gRPC client that will be able to talk with our SATLINK Docker. Then, so you will do an apply security request of your frame. It will secure your frame and send you back the secured frame. Then, easily, you send it to your satellite. The satellite, what will it do? It will take the frame. Again, as for process security, it will check authentication, decrypt the frame, give you back. Then you do what you need to do with your frame. And when you need to send back telemetry, same thing. very easy. You apply security on it, we give you back the secured frame, and then you send it. This is just a duplication, so for readable reasons. And it will do the same thing. So you will get the secured frame, you will process security on it, and get back the verified and decrypted TM. So easier you can do. Then let's see for extended procedures, because we said that that is also a very good part, an important part of managing the security of your channel. So for this, we actually developed this SATLINK CTL tool. And this just lets you do very easy gRPC commands, so that, for instance, you will just say, SATLINK key inventory. I want to know what are the different keys that are active on my satellite. Then I will just do that request that I just said to the SATLINK Docker. This will create a custom frame that we call an extended procedure PDU, and that we will give you back. And this is basically then will become a telecommand, as you usually do, and then you will do the same process that we said before. You apply security on it and send it whenever you want. When we have this extended procedure that is encapsulated in a TC and secured, we can send it to space. Space, we do again the same thing. We process security, so we check its authenticity and we decrypt it. And then basically we said that we will have a specific channel for extended procedure. So seeing that we can then send back this extended procedure to SATLINK to be able to check the active keys. That's what we ask for. So it will check the active keys and then give you a reply. And this again, like the other one, you will be able to encapsulate it in a normal TM and apply security on it, and so it can be sent back to the ground. So now the ground gets a secured frame. Again, it processes security, and then, knowing that it's come from the extended procedure channel, can just read the reply. So it's made so that it doesn't change too much the workflow that you're doing. The only thing is that just before actually sending the frame, you're securing it. So now let's see, because of course you're putting a binary to your satellite. So you're asking yourself, okay, put something else. How much memory does it take? And so here you see that it's actually less than 200 kilobytes of space, and then for the memory, because of course you need to be able to store the keys and the security associations, then we just suggest different levels of security. Let's say if you want to have a very, very strong security setup, of course, maybe you want to upload a lot of keys, and that will take more space to you. If you want to have like basic security, maybe you will upload less keys, and so that will take less memory space. So that's, again, according to your needs and the compromise that you do between the memory footprint and the actual security that you would like to have for your specific missions, because, again, all the missions will not have the same security sensitivity. Here you also see a bit that our structure is thought to be modular. So you see that basically we have the SA store, where we have the security associations, the key store, and then the cryptographic backend. I would like to stress this cryptographic backend, because the fact that this is modular, basically here we propose the, let's say, the solution with the software cryptographic backend. But if you would like to have it hardware, then it's very easy to just link it, because we will just interface your cryptographic hardware with this backend, and so you can basically also be able to adapt the different needs of the security with SATLINK. So if we just recap everything, a little step-by-step guide of how you can use SATLINK, you will just tell us, of course, the compilation and architecture flag that are used by your architecture, so that we can compile correctly SATLINK. Then you will be able to pull also the Docker to have the ground component. You will define the configurable parameters that we talked about to choose a bit the different length of the parameters in order to know how much security or like compromises you would like to do. You will also choose the different algorithms you would like to have for the cryptographic operations, and you will generate the cryptographic keys you need. With that setup, then you can just adapt a bit the workflow in order to be able to call SATLINK and actually secure your frames before sending them, and basically that's it. So, has it been used? Well, yes, it was used the first time in 2023 on the ARCA satellite. So on that, there were almost a million TCs and TMs that were processed, and the idea was to actually look at valid frames and invalid frames and ensure that the valid frames were correctly verified and decrypted, and that the invalid frames were properly rejected. And then we also looked at the different throughput and the difference between the apply and process security, and you can see here that both are very, very similar in their operating time. So now this was the first, let's say, try-on as an in-orbit validation, and then we actually had it through CNES innovation project, deploy it on the USpace platform. So some of you may know USpace. It's a satellite manufacturer, which aim is to actually be able to produce one satellite per day. That's what they were saying. And so through this CNES project, we were able to actually deploy it and to test it end to end. So, of course, and this is a bit also to show you the basic procedure that will have happen then for all the integration. There is, of course, some like architecture looking, because we will need to have the integration of SATLINK. Then, well, this we finished doing the extended procedure through the project, but for you, everything will already be covered and done. And having the SATLINK CTL, that basically is this little tool that will help you do the commands easily. And then actually integrating it. So with USpace, we had a real-time environment and also a hypervisor. So we had a specific partition in which it was running, and that also we needed to test that it will go smoothly within the entire platform functioning. And then, of course, doing end-to-end testing. For the end-to-end testing, we actually do several layers of testing. So isolated testing of both of our components, and then we also have some, let's say, frameworks that let us also, on your side, do some autonomous testing with some scripts that basically you can run to ensure that that SATLINK is correctly working when it is integrated into your architecture. And so then, what's next? Well, of course, as I told you, now that the process is clear, is done, there can be more integration and IOVs. We're actually on another CNES project with an in-orbit validation. And then we are also working on the deployment on a constellation with another project with constellations, global and lean space. And we are also wanting to put more innovation. And now let's say that we have covered the standard to go further the standard. So with FPGA deployment, we have that innovation project, and that will be actually presented to you in a couple of presentations by Jan. And the idea is also to be able to include asymmetric cryptography, plus quantum cryptography, and also include some AI to be able to monitor logs faster. And also a little addition to these bullet points, we will also be publishing open source, the basic procedures of SATLINK. So basically the idea is to let any, let's say, actor, whereas it is academic or industrial, to be able to use SATLINK for the, so apply and process security, but the extended procedure will still remain within the commercial product. But yeah, the idea is to be able to put access to security between ground stations and satellites more easily and more open to everyone. So with this being said, thank you very much for your presentation. Yeah, I actually had a conclusion slide. So now you know what is CCSDS and SDLS. You know what is ARCA SATLINK. You know what it does and how you can deploy it to you. So if you have any infrastructure that you would like to try it out and secure it, please let us know. And also if you have other innovation projects around the topics that I said before, or new topics, we're also very keen on having more innovation and continue building on more security into the space ecosystem. So again, thank you very much for listening to me. And if you have any questions, please come to talk to me or any one of our team.
Thank you. Thank you, Anna. Anyone has questions now? I have one question there.
Thank you for the presentation. Are you planning to develop a qualification package for ECSS category B or something like that?
Okay, so for now, yes, I didn't talk about certifications or qualifications, etc. But yes, of course, it is on the pipeline and on the roadmap. For now, let's say certifications usually take also a lot of time and a lot of money. We're still, a startup, so we're building this, and yes, we would very much like to do some qualifications and also maybe like a partner with some people to put that into a project. So if you also have some needs of like qualified products, of course, like we'll be more than happy to engage into that.
And do you have an expected date for the post-quantum cryptography inclusion? Because you mentioned it in the roadmap, I just imagine it's like far future or...
So we already working on it on innovation projects. So I would not be able to give you a ready date for like production ready. But yeah, that's something that we're already working on currently.
Okay, thank you.
Any other questions?
Thank you, Anna, for the presentation. So since we are facing an increasing of satellite constellations, so how could the interference affect the encryption and decryption algorithms?
Okay, very good question. For now, indeed, all the projects that we've done are mostly linked on like one satellite. As I said, we have this one project on a constellation with, it will be on a constellation simulator. So there we'll probably see eventually some maybe challenges. For now, that's not something that we have tackled, but we tried every time to, let's say, optimize the processes to not, for instance, not write too much into the memory to like not affect it too much. And so we always try to do that. That is probably a subject that we will be tackling within the constellation deployment. So sorry, I cannot respond you to the question right now on something that would actually take action to mitigate that.
Okay, no worries. Thank you.
Any other questions? Yeah.
Yes, thank you very much for the presentation. I like the principle of the security association you described in your presentation. I've got a question. Why did you choose the GCM mod for advanced encryption system? Since we know there are issues with the nonce, what we call the initial vector, in this distribution of AES. Why did you choose this one?
Well, I would say, well, and also then maybe Luca can take over. But so it's one that is mostly used, and also that have been asked, because we are always very open to like our users, what they want to use, and that's also what has been brought. And what we do with the initialization vector is, of course, then we can just rekey and have, in order to avoid reusing the same IV for the cryptographic key. So, sorry, what? I didn't hear properly.
In this case, in this mod, there is no randomization of the initial vector, so it's a weakness. This is why I ask.
Okay, well then, yes, we have that, and the so for now we have normal IVs, and we have something on the roadmap to add randomness to the initialization vector, and even like to do a hybrid kind of IV where would have like a half random and half, let's say, standard. So yes, we try to think about it to, yeah, if that answers your question. Okay.
Any other questions? So there is one question online. It's the same than before. Will the slide will be available? Yes, it is recorded, and you should have the link for the video.
If
later
not,
on.
there's my no, not anymore. But you can come to me, and I will happily share the slides.
On CYSEC booth.
Yeah.
Thank you very much, Anna. Thank you for your time, and we have a small break.